Good morning, geometry. Here we are. We're ready to jump into solving right triangles. And what is a solving right triangle? Why is that useful, you might ask? Well, let me just let you know, when you solve a right triangle, you're finding any missing pieces of the right triangle, anything that you don't know. You're going to be able to find missing lengths. You're going to be able to find missing angles. Why that's useful is that things can be measured that you can't necessarily get to. Okay, they can use that to find the heights of mountains without actually climbing up, or various different things. Surveyors can use them to set out boundary lines and things like that. So the idea of solving a right triangle can be very useful to you. We want to go to the idea of those trigonometric ratios, the sine, the cosine, and the tangent, in order to be able to do that. So let's just get going on this. Now, 30, 60, 90 triangle is a super important triangle. We've talked about that before, and I want to remind you a little bit about what you know about a 30, 60, 90 triangle before you are able to find by hand the sine, the cosine, and the tangent of 30 degrees, which is kind of a neat process. But if you'll remember, when you have a 30, 60, 90 triangle, there's proportions, specific proportions to the side. We talked about that in another chapter. Okay, the side across from the 30 degrees was your X side. It also happens to be the opposite side when we're talking about the 30 degrees as being things we're basing off of, so we can take care of both things. So across from the 30, you've got an X. The hypotenuse in the 30, 60, 90 triangle is going to always be 2x. And as I said, it's also the hypotenuse. That leaves the other side, if we're basing things off of the 30, as being your adjacent side. And remember that x square root of 3 is the way that we were finding that third side of a 30, 60, 90. This only works for 30, 60, 90 triangles. But because this triangle is so important, it's a very good place to start, and it's something that should be a little more familiar to you. Now remember, our sine is the opposite side over the hypotenuse. Opposite over hypotenuse. X over 2x. Now it should be a pretty simple thing for you to simplify that, because the x's can cancel out, and that just leaves you with 1/2 or 0.5. Okay, so you can do these, at least in the fraction form, pretty easily by hand. The cosine, remember, is adjacent over hypotenuse. There's your adjacent, and there's your hypotenuse. The x's will cancel. That gives you the square root of 3 over 2. Square root of 3 over 2 will be important if you go that road in your maths, if you head down the calculus road. However, our decimal form of it is also important. So we want to be able to take the square root of 3 and divide it by 2. And this is semi by hand, but 0.8660, not using the sine or cosine or tangent button at all, but being able to figure it out and make sure that it works. Tangent is opposite over adjacent. Opposite over adjacent. The x's cancel out. 1 over the square root of 3, and we can divide that out. 1 divided by the square root of 3. 0.5774. Don't forget to use your rules of rounding correctly. Okay, so you can find them sometimes almost by hand, but we're also getting used to using the sine, the cosine, and the tangent buttons on your calculator. So another way of finding them is to use your sine, cosine, and tangent buttons. Now we know what values we're expecting. Don't forget to make sure that your mode is set on degrees. If your mode is not set on degrees, like for example, it's radians here, and if I try to take the sine of 30, it's going to give you something completely wrong. Okay? That is wrong because we're in the wrong mode. We have to make sure we're in the right mode. I'm going to clear that out. Go to the right mode. Your mode needs to be in degrees because we're working in degrees here. Once you set it on your calculator, you leave it alone and it stays there. That's a good reason for you to have your own calculator. And we do 30, sine of 30. And we get our 0.5. Practice with your cosine. You always want to practice with whatever you have and make sure that you know what you're doing. Because if you ever come into a test quiz, whatever, SATs, and you haven't practiced with the right tools, then you're going to be spending valuable time trying to figure out your specific calculator rather than actually doing the problems. Okay, so there it comes out very quickly. If you have a phone calculator, because right now I know we've got some of you on that, don't forget we're looking to make sure we're on degrees. Under your trigonometry, you have sine, cosine, and tangent, but you have to put the numbers in first. So I want to put in 30, and then I want to find the sine of it. Okay. Or I can put in 30, and then I can find the cosine. Or I can put in 30 and find the tangent. Okay. So there's those things, how to do that on either one. All right, now the bulk of our time today though is going to be doing what we call solving a right triangle. And solving the right triangle means to find any side and angle that's not given in the original information. So I have a triangle, a right triangle, with an angle of 65 degrees for one of its angles, one of its acute angles, and the hypotenuse is 15, and we're supposed to find this side and this side. So there's a series of steps that you need to do when you are given one angle and one side, and you need to find the other two sides and the other angle. All right, today that's what we're going to be dealing with. Tomorrow we're going to be trying to deal with what if you're given two sides and you need to find the angles and you need to find the third side. So today let's just focus on you're given an angle and at one side, you know it's a right triangle, and trying to figure it out from there. Okay, first of all, you should put in some labels so that you have some variables to work with. Okay, across from the capital E, put in a lowercase e. Across from the capital D, put in a lowercase d. And this is just your little list of the things that you're trying to find. You're trying to find EF, you're trying to find FD, and you're trying to find angle D. The reason to pick variables is because it makes it much easier to work with and much easier to solve for. Okay? You want to then look at the angle that you are given, and you want to label your opposite and adjacent and hypotenuse based off of the angle number of degrees that you have. So you want to say, all right, I want to find things based off of 65, so I should label opposite, adjacent, and hypotenuse. Hypotenuse is the easiest, longest side of the right triangle. The side opposite is the one that's furthest away, and that leaves this one for the adjacent, so you label those sides. Well, what's that going to do for us? What that's going to do for us is allow us to set up some equations to solve. The equations themselves are not difficult to solve once you have them. Okay? You look at the things that you have. You have a hypotenuse. So that means the trig ratios that will be useful to you will be the ones that include hypotenuse in them. Remember, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So the sine and the cosine are both going to be very useful in solving these. we're going to use that trig ratio to solve for one of the side lengths. So if I'm looking here and I'm thinking, okay, let's think through my trig ratios. Sine is opposite over hypotenuse. Okay, opposite is a variable, but hypotenuse is a number. Okay, I'm going to go with that one. So I know that the sine of 65 degrees equals E over 15. That's what you're starting with. We have just one variable, and everything else can be handled with the calculator. When you put your number in, we can take the sine of 65. This is why we wanted to be able to find this by calculator. And we get 0.9063. I do want you to go ahead and do 4 decimal places. It's just a good fine enough number to make the answers come out to be good, and then we're all dealing with the same answer when we do the work. So 0.9063. Then you're trying to get E by itself. So we do that by multiplying both sides by 15. And so your final answer is, what we get when we take 15 times 0.9063. And I'll show you a trick with this calculator that you're going to love in a minute. Okay, so when we get your final answer for a side length, round that to the 10th place. So 13.6. And we'll just try to make it so that we have our side lengths rounded to the nearest 10th. So this E is 13.6. That means FD is 13.6 centimeters because it's a length and it matches this. Now if we're trying to find EF, we're trying to find D. Let's think about the things that we're given. We're given 65 adjacent, and we're given the hypotenuse. Adjacent over hypotenuse is cosine. Cosine 65 is D over 15. From your calculator, I'm going to put in cosine 65. Now, like I say, remember this only works if you have the right mode set. 0.4226. All right, now I'll show you this cute little hint that on this calculator. It doesn't work on all calculators. It works on the TI-83 Plus and the TI-84, and I want to teach you how to use this in the most efficient way. If I want to multiply 0.4226 times 15, and I just push the times button, notice that it says ANS. That stands for answer. What it means is it takes the answer that you just got, and then it's going to multiply by whatever it is that you put in. So this is the same way as taking 0.4226 times 15 without having to go through and put those things all in again, and you get 6.3 if we round it to the 10th place. Now, I saved the easiest for last. The easiest thing is to find the other angle. The reason I saved it for last is that sometimes people go for the easiest first, but then get confused with opposite, adjacent, and hypotenuse and start getting all kinds of wrong answers because you now have another angle to think about and it gets confusing. So if you save solving that last angle till the end, it keeps you from getting yourself into trouble. So our last angle is just simply these two angles together have to add up to 90, because altogether in a triangle you have to get 180. This one's already 90, so all you have to do is take 90 minus 65 and give you your answer there, your 25 degrees. Okay, that's old news. Okay, this is sine, cosine, and tangent. What you need to do in order to find two missing sides and a missing angle. We're going to do one more, and then you'll be able to look through and get a start on the assignment so that you can begin to master it. Tomorrow will be part 2. where we have two sides and no angles, and you have to find the angles and the sides. But for right now, you'll have an angle and you have one side, and that's what we need to focus on for today. So here's a problem for you. I have 35 degrees. I know I've got my one angle, and I have my one side. Now let's think about what our steps were. Our steps were to give it some variables. Okay, here's a variable A. Here's a variable C. This one already has a number in it. 35 degrees, you want to find your opposite, your adjacent, and your hypotenuse based off of the 35 degrees that's given. Hypotenuse, okay, hypotenuse, longest side of a right triangle. Go all the way across the triangle, there's your opposite side, and your adjacent side is the side next to the hypotenuse, or next to your angle. All right, so let's start thinking. I've got adjacent now. Sine isn't going to help us because sine is opposite over hypotenuse. That would give you A over C, two variables, too much. So what we need to do is we think, all right, what about cosine? Cosine, adjacent over hypotenuse. That gives me just one variable. So I'm going to use cosine of 35 is 19 over C. All right, now I need to solve for C. And that's an interesting thing to do. Let's get this turned into a decimal first. Cosine of 35. 0.8191. 0.819. This actually should be 0.8192, shouldn't it? Change that to a 2. Because we use our rules of rounding, right? 0.8192, 5 and up rounds up. All right, so after you have that, what you need to do, be careful. The mistake that a lot of people want to do now is multiply both sides by 19. But multiplying by 19 is not going to cancel it out. We need to multiply both sides by C. Okay, why do we need to multiply both sides by C? We need to multiply both sides by C because C is in the denominator right now, and it'll just mess you up if you don't. Let me change this back to a 2. All right, so once I've multiplied both sides by C and it cancels out, I need to then divide both sides by 0.8192. So I'm going to divide both sides by 0.8192. Here's the thing. There is a trick to this, but since you're just learning, let's show you the long way first. It's not really much shorter actually, because you're dividing by the last answer. So you're a little safer just doing 19 divided by 0.8192, and we get 23.2. All right. Now, as C is 23.2, that's this one, that's our hypotenuse, that's side BA. There's our 23.2. All right, so for part, this one, for BC, I have my adjacent and I have my opposite. And so we've done, sine isn't helpful, cosine we used, tangent, opposite over adjacent. Let's do tangent. A over 19. So you want to find the tangent, another calculator exercise. So we're going to do tangent of 35. 0.7002. Okay. Then we need to multiply both sides by 19. This one is the one, you know, you're not trying to move the variable up or anything like that. So you can just do that one. Answer times 19. So 13.3. So we have 13.3 for this one. And then finally, your missing angle, you need to just take 90 minus 35. And 90 minus 35, 55. And you've got your final answer, 55 degrees, and you found your missing parts. So congratulations, we've just gone through the processes for solving a right triangle when you're given one angle and one side. Okay? Tomorrow we're going to pick up with trying to find the missing angles if you're given side lengths. A different process, but we're halfway there, and this is enough for you to chew on. Make sure that you really understand what is happening. Make sure that you practice on your calculator. Okay, and remember I told you that if you don't have this type of calculator or the TI-84 or the 84 Plus, make sure that you, or the one that recharges too, that's an 84, make sure that you have one for Algebra 2 next year. Okay, that's it for today. Have a very good day. God bless you.